everyone. So this week is going to be kind of a review week. So at the beginning of our distance learning, we talked about factoring. And 2 weeks ago, we did our solving quadratics by factoring unit. This last week, we did solving quadratics by quadratic formula. And so this week is going to be our third week in solving quadratics, and we're just going to combine the two. And so I'm calling this week solving quadratics using any method. So we're going to practice saying, okay, we have a quadratic. How are we going to solve this? We have two options. We can either try to factor it, or we can use quadratic formula. And yeah, so hopefully through some examples, you guys will see like when one is better than the other. You guys might already know. I've talked about it a little bit. But real quick, I just want to do some factoring review and some quadratic formula review, just to make sure that we remember how do we solve by factoring, recap how to solve by quadratic formula, and then we'll move into practicing this week's ideas. All right, so some factoring review. Some things to keep in mind when you factor, your a value has to be 1. So the a value chilling out front here, it's just x squared, so your a value is 1. And so then the trick is, you make a diamond puzzle. So it multiplies to 24 and adds up to negative 10. So remember this, so you want to multiply to a positive, add up to a negative. So that's your hint that both pieces are going to be negative. So it multiplies to 24, adds up to negative 10 is negative 6, negative 4. So your chunks are x minus 6 and x minus 4. Remember, that's in no particular order. And remember, you have to keep it set equal to 0 because we're solving technically. And so because we have 0 equals our two chunks, that means you can break it up into two equations. One does x minus 6 equals 0, and one does x minus 4 equals 0. So you solve for both. For this one you add 6. So this one, x equals 6, add 4. This one, x equals 4. So your two solutions are x equals 6, 4. So this is solving by factoring, which I think is the easier method. This is the preferable method, and you guys are really good at diamond puzzles. The second method, quadratic formula. So when you see a quadratic, the easiest thing to do is factor. But as you guys know, hopefully by now, not everything factors. So if you take a look at this, we could attempt to factor it, right? But to factor, your a value has to be 1. Right now, your a value is 2. So you could GCF and see if it factors. But you guys, whenever your a value isn't 1, just go ahead and do quadratic formula. That's going to be the most time saving. So quadratic formula, I'm going to write it up here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is the quadratic formula. And so again, this week, you'll need this formula somewhere. So if you want to have like old notes pulled up, you're going to be using the formula a lot again. It's going to be a mix between factoring, quadratic formula. So the first step of quadratic formula is to find the discriminant, which is the part that lives under the square root. So first up, we want to find b squared minus 4ac. So our a value is 2, your b value is negative 9, and your c value is negative 20. So first up, we want to find b squared minus 4ac. So we've got negative 9 squared minus 4 times 2 times negative 20. So this is when we head back to Desmos. I'm going to try to move my phone so that you guys can see Desmos. All right, so we've got, I have to tilt a little bit, sorry. There we go. All right, so parentheses, negative 9 squared minus 4 times 2 times negative 20 is 241. All right, so our discriminant is 241, so then we head back to our paper. So discriminant's 241. It's positive, so that means there's two solutions. All right, so if there's two solutions, that means we have to keep solving. That means there's an answer, so we're going to use the quadratic formula now and find those two solutions. So x equals, the first thing I'm going to do is I'm going to plug 241 in for the discriminant. So I'm going to leave negative b plus or minus square root of b squared minus 4ac we found was 241. So I'm going to plug that in all over 2a. And so now this is when I go in and I replace b and a. So x equals negative, and then set up some parentheses. Your b value is negative 9 plus or minus square root 241 all over 2 times a, which is 2. And then real quick, I like to simplify, just like a negative and a negative makes a positive. So x equals 9 plus or minus the square root of 241. All over 2 times 2 is 4. So like I said, normally this is where I would just have you guys leave your answer, but because we're doing online stuff, it asks for decimals. So you need to plug it into Desmos to get your decimals. So this is where you break it up into the 2 pieces. 9 plus root 241 all over 2. And then 9 minus root 241 all over, oh, it's over 4. My bad. Over 4. All right, so then we're going to go to Desmos and type these in. So, go into Desmos. Remember, you have to put parentheses around the top. So, 9 plus SQRT. Oh, 9, not negative. 9 plus SQRT 241 divided by 4. So, we get 6.1310 blah. I'm going to round to a couple decimal places. So 6.131. 3 decimal places, sure. And then we need to find the negative one. So I'm going to backspace the plus, minus. And we get negative 1.631. All right. So there's our answer on our paper. So for the positive one, we got 6.131. The negative one, we got negative 1.631. All right, so this is just a recap on the 2 different methods of solving. So if your a value is 1, you can try to factor it. Now remember, not everything is factorable, even if the a value is 1. That's just when it's smart to try to factor. And if your a value is not 1, we're just going to go ahead and use quadratic formula. It ends up being easier, believe it or not. All right. So I gave us some steps for solving any quadratic. So if we want to solve any quadratic, the first thing is that you have to set it equal to 0. So starting this week, I'm not going to give them to you guys just already set equal to 0. So everything you've seen so far is the quadratic equals 0. More often than not, if you start to look at the examples, they're not set equal to 0. We have to move stuff around and get it set equal to 0. So that's going to be step 1. Step 2, identify a, b, and c values, label a, b, and c. 3, if your a value is 1, try to factor. Real quick, set up a diamond puzzle, see if you can come up with something. If you can't come up with something, either A, because it's too tricky, or B, it might not exist. If there's some reason why you can't quickly solve the diamond puzzle, just forget it. Instead, use quadratic formula. And if your A value is not 1, don't bother trying to GCF and then factor or something. Just go ahead, use quadratic formula, because no matter what, you guys, the quadratic formula will always work. So even for problems that factor, you could do quadratic formula, you'll get the same answer. So for example, for this problem, if we hadn't have factored this, we could have used quadratic formula. You would get the same answers. You would get 6 and 4. It's just a lot of work because you'd have to type this into Desmos. It's just when you typed it in, you would get 6 and 4 and not some crazy decimals because it was able to factor. We just chose a different method. But so anyways, let's try some. So first up, step 1, set equal to 0. So right now we have r squared minus 12 equals negative r. So they give a couple options. You can always move the stuff on the left to the right and get it set equal to 0, or move the right to the left. It doesn't matter. So I could subtract r squared and add 12, or I can just add r over. You can move anything either direction, but there's usually always a simpler method. So the direction that requires the least amount of work is just to add r to both sides. So negative r plus r cancels out and you get 0. What you do to one side, you have to do the other. The problem is this side doesn't have an r family. There's an r squared family and a constant family. So I'm just going to add r to the outside. And then we should write things in standard form. So when we rewrite this side, you start with the biggest exponent first and the next biggest exponent and so on. So the biggest exponent is the squared. So the first term should be r squared. And then we have a plus r and a negative 12. So what should come next is the next biggest exponent, which is plus r, because that has an exponent of 1. And then negative 12 technically has an exponent of 0. All right, so we moved the r over. We've written it in standard form. We can now solve our quadratic because it's set equal to 0. So I'm going to identify the a, b, and c values. A is 1, b is 1, C is negative 12. So now we're going to stop. So this is step 2. Step 3, if your A value is 1. Is our A value 1? Yep. So let's try step 3. Let's try to factor. So I'm going to set up a diamond puzzle. So what multiplies to negative 12 adds up to 1. Does that work? Can we find two numbers that multiply to negative 12 and add up to positive 1? The answer is yes. 4 and negative 3. 4 times negative 3 is negative 12. 4 plus negative 3 is 1. So this one's nice. We can just solve it like this now. Our chunks are x plus 4, x minus 3, and it equals 0. You set your two chunks equal to 0 and solve. So subtract 4. So x equals negative 4. Add 3 to both sides. X equals 3. So your solutions are x equals negative 4 and x equals 3. So this one's nice. We got it set equal to 0, and then we ended up with a quadratic that we could factor. Yay! All right, let's try another one. I'm gonna move some stuff. There we go. All right, this problem. So there's stuff on both sides, and it's not set equal to 0. One of the sides doesn't have equals 0, so we can't start solving yet until it's equal to 0. So we've got x squared plus 4x minus 10 equals 3x minus 7. So some strategy here is asking yourself, like, which side should you move stuff from? So this side has 3 pieces, this side has 2, so it's easier to move the 2 over than the 3 pieces. So I'm just gonna do the opposite signs of these ones and combine like terms with their families over here. So we've got 3x, so I'm gonna subtract 3x. That cancels out. Where do we subtract 3x from? This is in the x family, so go find the x family. X squared, x. So 4x minus 3x. And then it's negative 7, so I'm gonna add 7. And 7 belongs to the constant family, so I'm gonna add 7 to the constant family. We didn't do anything with the x squared family, so x squared just comes down, x squared stays the same. So we've got x squared. 4x minus 3x is 1x, and then negative 10 plus 7 is negative 3 equals 0. Sweet. All right. So now that we've got it set equal to 0, so that's step 1. Step 2 is identify the a, b, and c values. So a is 1, b is 1, c is negative 3. Step 3, if the a value is 1, try factoring. Well, a value is 1, let's try factoring. Multiply this to negative 3, adds up to 1. Well, the only way to multiply to negative 3 is to do negative 1 times 3, or 1 times negative 3. Well, negative 1 plus 3 is 2, and 1 plus negative 3 is negative 2. Neither one of those add up to 1, so we can't factor. That doesn't work. There's no way to multiply to negative 3 and add up to 1. So it doesn't factor, so step 3 doesn't factor. Sad face. Factoring's easier, right? So then step 4, now we have to do quadratic formula. So it doesn't factor, so now we have to rely on quadratic formula. I don't know if I have room to show all my steps here. So we have our a, b, and c values. Here's your nice quadratic. So let's start by finding the discriminant, b squared minus 4ac. So b is 1 minus 4 times 1 times negative 3. This one we probably don't need Desmos for. 4 times 1 is 4. Negative 4 times negative 3 is 12, so 12 plus 1 is 13. So your discriminant is 13. Like, you can use Desmos. You could plug this into Desmos if you needed to. So discriminant's 13. So plugging into quadratic formula, x equals negative b plus or minus the square root of 13 all over 2a. And then let's plug in negative b value is 1 plus or minus the square root of 13 all over 2 times a value is also 1. So let's simplify. Negative 1 is negative 1 plus or minus square root 13 all over 2 times 1 is 2. So this is what you'll type into Desmos. You'll do negative 1 plus root 13 over 2, negative 1 minus root 13 over 2. So Desmos time. I'm just going to backspace the one I've already got here. So we've got -1 plus square root of 13 all over 2. So the first one is 1.303, rounding correctly. And then minus backspace -2.303. So we've got 1.303 and this one was -2.303. And those are your two answers. Woo! All right, so I'm gonna do a few more examples with you guys. I tried to put one that's gonna be on your homework problems, like one of each. All right, so this first one, once again, your quadratic is not set equal to 0. So this side has 3 pieces, this side has 2, so I'm just gonna move the side that has 2. With positive 10x, I'm gonna subtract 10x, cancels. I'm gonna take the 10x from the x family. So here's the x family, so minus 10x. I'm gonna add 9, so I'm gonna add 9 to the constant family. And again, we didn't add or subtract anyone from the x squared family, so I just bring it down. So we've got 10x squared, 4x minus 10x is -6x, and then -1 plus 9 is 8 equals 0. Sweet. So that's step 1. We got it set equal to 0. So step 2, label A, B, and C values. A is 10, B is -6, C is 8. Rad. Okay, well the next step is if your A value is 1, try factoring. Well, with our A value 1, definitely not. So step 3, no factor. A value is 10. So don't worry about trying to factor. A value is 10. I'm not going to worry about that. So let's just go straight into step 4, quadratic formula. So we start by b squared minus 4ac. B is -6 squared minus 4 times 10 times 8. That one I don't know off the top of my head. Let's go back to Desmos. So I'm going to plug it into the top one here. This is my discriminant one. We've got -6 squared minus 4 times 10 times 8. Oh, sweet. All right, we end up with a negative. So we get -284. So our discriminant gives us -284, and that means there are no solutions. And we're done. That's our final answer. Remember, if you get a negative discriminant, negative means no solutions. And then we don't have to keep solving. We're just done. Sweet. All right, let's keep going. This example, it's not set equal to 0. Like I told you guys, I'm not going to give him set equal to 0 anymore. This one is like equally balanced, right? Like there's 2 pieces over here and 2 pieces over here. So it literally, like, it's not easier one way or another to move these 2 there or these 2 there. Like, it really doesn't matter. I'm going to move this side over there. It doesn't matter. You can move these ones over there. You're going to get the same answer. Either way, I usually just pick one side that has the least amount of pieces. But like I said, they're equal. So I'm going to subtract 30. And so subtracting 30 over here, there's the n squared family and the n family, but there's no constant family over here. So I'm just going to throw it out front that we're going to subtract 30. And then I'm going to add 4n squared. And I'm going to the n squared family, add 4n squared. So I'm going to write it in order. The -30 should go on the end, right? So -3n squared plus 4n squared. -3 plus 4 is 1n squared. And then the n, we didn't add anyone, so plus n, and then that -30 equals this side canceled, so it's 0. All right, so that's step 1, is getting it set equals 0. Step 2, A, B, and C values. A is 1, B is 1, C is -30. So this one, so step 3 says check your A value. A value is 1, so let's try factoring. Let's set up a diamond puzzle, see if we can figure it out. What multiplies to -30 and adds up to 1? Well, things that multiply to make 30. 10 and 3, that's not going to add up to 1. 5 and 6, oh, that is a difference of 1. So let's think about 5 and 6. And one of them needs to be negative because it has to multiply to -30 and add up to +1. So I'm going to make the 5 negative. -5 times 6 is -30. -5 plus 6 is 1. Great, this one factors. Sweet. So step 3 works. And so my factor chunks are x minus 5. Oh, I guess it's not x, it's n, huh? N minus 5. N minus 5 and n plus 6 equals 0. And then you set each chunk x equal to 0. N minus 5 equals 0. N plus 6 equals 0. Add 5. N equals 5. Subtract 6. N equals negative 6. And you're done. Those are your two solutions. Woo! It's very nice when it factors. It's a lot easier. So don't forget to check. If your a value is 1, you can try factoring. You don't always have to do quadratic formula. That's why I teach you both, because sometimes it factors, and that's a lot easier. All right, 2 more examples. This one is kind of the same case. There's 2 chunks over here, and there's 2 chunks over here. There is a little bit of strategy here. I mean, it really doesn't matter. I don't like to move the squared term if you don't have to. So this side has the 6v squared. So I'm going to move these ones out. It really doesn't matter, though, because the a value is not 1. It's going to be quadratic formula. So whatever you guys feel. So I'm going to subtract 4v. So then I'm going to subtract it from the v family over here, minus 4v. And then subtract 9. There's nowhere to subtract 9, so I'm just going to throw it out, to the side. We didn't change any of the v squared family, so I'm going to bring it down. 6v squared. 7v minus 4v is 3v positive. And then that minus 9 equals 0. So that's step 1. Step 2, a, b, and c values. A is 6. B is 3. C is negative 9. Your a value is not 1, so step 3, no factor. Your a value is 6. So let's just go straight into quadratic formula. So start with discriminant b squared minus 4ac. So 3 squared minus 4 times 6 times negative 9. All right, Desmos time. I'm gonna head over to Desmos and find my discriminant. So I usually just leave like a discriminant one on Desmos and then like the final product one on Desmos and just backspace. It tells you like equals, like they're separate. So we've got 3 squared minus 4 times 6 times negative 9. So we get 225. All right. So our discriminant for this one equals 225. It's positive, so there's 2 solutions. So let's keep solving to find those 2 solutions. So x equals negative b plus or minus the square root of 225 all over 2a. So x equals negative, and then the b value is 3 plus or minus square root 225 all over 2 times a is 6. So I'm going to simplify this a little bit. Negative 3 is just negative 3 plus or minus square root 225 all over 2 times 6 is 12. So you guys know, break this into the 2 pieces. Negative 3 plus root 225 all over 12. Negative 3 minus root 225 all over 12. All right, so we'll go to Desmos, type these 2 in. So the first one is negative 3 plus the square root of 225 all over, all over 12. Oh, okay, so we get 1. And then subtract. Negative 1.5. Those ones are nice. So the first one is 1. This one is negative 1.5. Those are what x equals. And we're done. X equals 1 and negative, oh, did I put a negative? No, that's negative 1.5. 1 and negative 1.5. All right, last one. This one. So we've got x squared minus x minus 15 equals 5. We need set equal to 0. We could do that pretty quick with this one. I'm just going to subtract 5 and then subtract 5 from the constant family. Bring the x squared and x families down because we didn't mess with them. So x squared minus x, and then negative 15 minus 5 is negative 20 equals 0. So that's step 1 equals 0. Step 2, a is 1, b is negative 1, c is negative 20. And so step 3, check to see if your a value is 1. It is, so let's try diamond factoring. multiplies to negative 20, adds up to negative 1. Well, what multiplies make 20? 2 and 10, not going to be that. 4 and 5. Well, 4 and 5 have a difference of 1. So let's try 4 and 5. So 4 times 5 is positive 20, so we need one of them to be negative, then add up to a negative 1. So if it's negative 5, 4 times negative 5 is negative 20. 4 plus negative 5 is negative 1. So it factors, yay. So our chunks are x plus 4, x minus 5, and then equals 0. And then we just take our two chunks, set them equal to 0, x plus 4 equals 0, x minus 5 equals 0. Subtract 4 from both sides, x equals negative 4, add 5 to both sides, x equals 5, and those are your solutions. All right, so this week there's nothing new other than when I give you a quadratic, it's not just going to be set equal to 0, so you have to do some combining like terms. And then asking yourself, should you factor, should you use quadratic formula? And so remember, if your a value is 1, try factoring. It works a good amount of the time. Remember, not always. On the front, oh, I have separate sheets. On the front, we came across one that didn't factor. The a value was 1, but it didn't factor. So if you're struggling, I would just stop. Like if for some reason you can't figure out the diamond puzzle, just stop and do quadratic formula. Even if it did factor, you'll still get the right answer, so no worries. Worst case, you guys, if you don't like factoring or factoring isn't working out for you, just use quadratic formula for every problem. The point of this week is to show you that it doesn't always have to be set equal to 0. You can combine like terms and get it set equal to 0. And then sometimes you don't always have to use quadratic formula. If your a value is 1, try factoring because factoring is a little bit easier. If it doesn't work, we can always rely on quadratic formula. All right, guys, good luck this week. Let me know if you have any questions. Make sure you try some of the homework questions, and have a good week.